Vanakkam, Vandanam, Namaskaram. You are watching Nama channel.
Children, today we shall get into the topic playing with the numbers. Very interesting topic. Dear children, mathematics is not just about addition, subtraction, etc. It is something more than that. It is very interesting and exciting and mind-blogging. Let us now begin with the study of playing with numbers. In this chapter, we study about alphanumerals and puzzles, divisibility tests and puzzles, and finally about the fascinating magic squares. In this capsule, we study about alphanumerals and puzzles. Nearly 2000 years ago, Julius Caesar was busy taking over the world, invading countries to increase the size of the Roman Empire. He needed a way of communicating his battle plans and tactics to everyone on his side without the enemy finding out. So, Caesar would write messages to his generals in code. Instead of writing the letter A, he would write the letter that comes 3 places further on in the alphabet, the letter D. When he go to the end of the alphabet, however, he would have to go right back to the beginning. So instead of an X, he would write A. Similarly, we have problems where letters represent digits which can be decoded. For example, find the values of the letters in the addition of 3a plus 25 is equal to B2. Here, we have to crack the code, that is, find the appropriate digits for the letters. Although cracking the code can be through trial and error method, a little logical thinking helps in getting quick results. Answer. Here is the stepwise procedure based on logical thinking. Step 1. In addition of A and 5, which is giving 2, this is possible only when digit A is 7. In that case, sum of A, that is 7 and 5, will give 12. And 1 will be the carry for the next step. Step 2. After replacing A by 7 and adding 37 to 25, we get 62. Hence, what is B here? B is 6. Therefore, A is 7 and B is 6. Children, here is one more example on addition. Find the value of A in 4A plus 98, which is equal to CB3. Answer. Here is the procedure. Step 1. The addition of A and 8 is giving 3 in the units place. This is possible only when digit A is 5. In that case, sum of A, that is 5 and 8, will give 13, and 1 will be the carry for the next step. Step 2. After replacing A by 5 and by adding 45 to 98, we get 143. Hence, C is 4 and B is 1. Therefore, A is equal to 5, B is equal to 4, and C is equal to 1. Children, let us now consider the addition of 3-digit coded numbers. Here is an example for you. ABC plus CBA is giving a sum 1242. Here, A, B, C are consecutive integers. In the third row, A, B, C appear in some order. Find A, B, C. Answer. Shall we get into the stepwise procedure? Yes, step 1. The sum of digits in the unit place is giving 2. Means C plus A plus another A or B or C is giving 2. And A, B, C are consecutive digits. If another A is considered, it becomes C plus 2A minus 2, which is not possible. Let A is equal to 3, B is equal to 4 and C is equal to 5. Since A, B, C are consecutive digits, if C plus A plus another A is considered, then we get C plus 2A means 5 plus 2 into 3, which is equal to 11. But we have to get 2 in units place. Hence C plus A plus another A is out of question. Similarly, C plus A plus C does not give 2 in units place. Similarly, 5 plus 3 plus 5, which is equal to 13, which is not possible. Step 2. Only C plus A plus B is possible in units place. Here C plus A plus B is equal to 3 plus 4 plus 5, which is equal to 12, and we get 2 in units place. Step 3. Now replace A, B, C by 3, 4, 5. In the two rows ABC plus CBA, we get 345 plus 543. Now, since the unit place of third row is B, it is 4. 5 plus 3 plus 4 is equal to 12 with carry 1. And 1 plus 4 plus 4 plus what is to be placed here is equal to 4 in the sum. Since this what should be 3 or 5. But only 1 plus 4 plus 4 plus 5 is giving 14. Hence, the tens place is C, means 5, and hundreds place must be A, means 3. Now, 345 plus 543 plus 354 is equal to 1242. Hence, A is equal to 3, B is equal to 4 and C is equal to 5. Alternate method. Let A is equal to 3, B is equal to 4, C is equal to 5. Then ABC plus CBA is equal to 345 plus 543, which is equal to 888. Now 1242 minus 888 is equal to 354. Hence, the third row is 354. Therefore, A is equal to 3, B is equal to 4 and C is equal to 5. Children, here is a practice problem for you. Find the value of A, B and C in 3A plus 98, which gives the sum CB3. Now here is the solution. Now we shall get into step 1. Since 5 plus 8 is giving 13 and satisfies the digits in the units place of the sum CB3, A should be 5 and carry 1 plus 3 plus 9, which is equal to 13. Hence, A is 5, B is 3 and C is 1. Therefore, A is 5, B is 3 and C is 1. Children, here is one more problem for you to practice. Find the value of A and B in 12A plus 6AB is giving a sum A09. Here is the procedure to find the answer. Step 1. Since A plus B is giving 9 in ones place of the sum and 2 plus a in tens place is giving 0 in the sum, a should be 8 and b should be 1. Step 2. Then 12a plus 6ab becomes 128 plus 681. Step 3. 1 plus 1 plus 6 is equal to 8 in the hundreds place. Therefore, 128 plus 681 is equal to 809. Hence, a is equal to 8 and b is equal to 1. Let us now consider some multiplication problems involving decoding of letters with numerals. Example, find the value of the letters in AB into 3 giving a product CAB. Here is the stepwise procedure to find a solution. Step 1. The multiplication of 3 and B giving B in ones place of the product CAB. Hence, B must be 0 or 5, since 0 into 0 is equal to 0, or 3 into 5 is equal to 15. Step 2. Let B be equal to 5. Then AB is A5 into 3, giving a product CA5 with 1 carry. Let us put some value, say 6 for A, then A5 is 65, and 3 into 6 plus carry 1 is giving 19, but we should get 6 for A. Step 3. To get 3 into A plus 1 is equal to CA, this is also not possible for any value of A, and for B is equal to 5. Hence, B cannot be 5. Therefore, the other option for B is 0. Then, A 0 into 3 is giving a product CA0. Step 4. If A is 0, the product is 0. But CA is a 2-digit number, hence A cannot be 0. If A is equal to 5, then A0 becomes 50. And 50 into 3 is equal to 150. Hence, A is equal to 5, B is equal to 0 and C is equal to 1. Children, here is a practice problem for you. First one, find the value of A and B in 3A into A is giving a product 2BA. Here is the stepwise procedure to find the answer. Step 1. Since A into A is giving A itself in ones place of the product, A can have values 1 or 5 or 6, but not 0, since 3A into 0 is equal to 0, and the product becomes 0, which is absurd. Step 2. 2BA in the product is a 3-digit number, hence A cannot be 1. Similarly, A cannot be 5 since 35 into 5 is equal to 175. But we have 2 in hundreds place. Hence, the only possible value for A is 6. Now, 3A into A becomes 36 into 6, which is equal to 216, which satisfies the product 2BA. Hence, A is equal to 6 and B is equal to 1. Children, here is one more practice problem for you. Find the values of letters A, B and C in ABC into AA, giving the product AC6C. Here is the stepwise procedure to find the answer. Step 1. The multiplication of C and A in ones place is giving C. Hence, A should be 1. Since a digit multiplied by 1 gives the same digit. Hence, AA is equal to 11. Step 2. Since the tens digit in the product is 6 and 9 plus 7 is equal to 16 with 6 in the tens place and 1 to carry, C can be 7 and B can be 9. Now ABC into AA becomes 197 into 11. 7 into 11 equals 77 with carry 7 and 9 into 11 is equal to 99 plus carry 7 which is equal to 106 with 10 to carry to the next place. Now 11 into 1 plus carry 10 is equal to 21. Since A is equal to 1, C cannot be 7. Hence, C should be 9 and B should be 7. ABC into AA with C is equal to 9 and B is equal to 7. We get ABC into AA is equal to 179 into 11. Now 9 into 11 is equal to 99 with 9 to carry. 7 into 11 is equal to 77 plus 9 which is equal to 86 with 8 to carry. 1 into 11 plus 8 is equal to 19. Therefore, AC6C is equal to 1969. Therefore, A is equal to 1, B is equal to 7 and C is equal to 9. Children, so far in this capsule, under playing with numbers, we have learnt alpha numerals and puzzles. In the next capsule, we are knowing about divisibility and puzzles.